Good morning, ladies and gentlemen. Welcome to week 14 of your SAT math prep sessions. This week's topic is going to be two variable scatter plots and lines of fit. Please make sure that your first and last name appears on the name line and that you've circled your teacher's name and your class names. Remember that if you have more than one, you are welcome to circle more than one. Please make sure as we go through these guided examples that you are taking notes, that you're writing down everything that I show you in the video, as these things will come in handy when you're working the skill check on your own. So, example 1. We've got a scatter plot here, and it says, which of the following could be the equation of the line of best fit for the data shown? Now notice that all four answers are in slope-intercept form, y equals mx plus b, which means we need to look at this data and we need to decide what the approximate slope and intercepts are. So the first thing would be, we need to take our straight edge and we need to draw an approximate line of fit. Now your answer is not going to be perfect, okay? But if you notice, we can draw a line in here and have a pretty decent idea of what we're looking at, okay? So here I've drawn a line, okay, and it goes through the data. Some data is above, some data is below, and it's not perfect, but it's a decent representation. Now there's two things that we should notice. Okay, first of all, we should notice immediately that this line is going downhill from left to right, which means that we have a negative slope. Why is this important? Because that means that immediately we can go over to our answers and we can cross out two of them because these two have positive slopes, which means they definitely are not the correct answer. So even if you have no idea what to do beyond that point, what you have done is you have managed to eliminate two of the three wrong answers, which means that then if you're forced to guess, the chance that you will guess correctly is now 50% instead of 25%. You have doubled your chance of getting the question correct even if you don't know what else to do. Now from there, what I suggest that you do is you grab 2 points, and it doesn't matter which two, okay, from the data, so that you can get an approximate slope, okay? And actually, now that I look at it, I think I'd rather use this one, which is the point 415, and this one, which is the point 10.5. And if I use those two and my algebra knowledge, I can find the approximate slope y2 minus y1 over x2 minus x1 using the slope formula. So in this case, that would be 5 minus 10, 15, 5 minus 15, over 10 minus 4. Now again, this is not going to give us an exact slope, okay? It gives us an approximate slope. The approximate slope is negative 5 over 3. Okay, so if we're looking at this and our choices are negative 2 or negative 1/2, we would ask ourselves which one is closer, and the answer would be negative 2 is closer. So we would rule out negative 1/2 because it's not steep enough, and we would pick choice A. Okay, so again, it's not an exact slope, it is an approximate slope. So the best equation for the line of fit for that data would be y equals negative 2x plus 23. Okay, so that brings us to example 2. It says the scatter plot to the left shows the number of grams of both total protein and total fat for 8 sandwiches on a restaurant menu. The line of best fit for the data is also shown. According to the line of best fit, which of the following is closest to the predicted increase in total fat in grams for every, those are key words, for every increase of 1 gram of total protein? So this is a really long question here. Okay, predicted increase in blah, 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 blah. Well, as soon as we see the words for every, we should realize they're asking us for a rate of change or slope. And then the word predicted, that tells us that we want the slope of the line of best fit. So this question is asking us to find the slope of the line of best fit. So if we look at the line, there are a number of points that appear basically right on the line. This point here is approximately 35.55. And this point down here, we could approximate pretty well as being, what, 9.15 maybe? So we approximate a couple of the points and we run the slope formula, just like we did a minute ago, keeping in mind that we're not going to get an exact answer. We're getting an approximate answer here. So y2 minus y1, remember that these 2 points here, doesn't matter which one's which, x1, y1, x2, y2, and we feed them to the slope formula. So we're seeing what? 55 minus 15 over 35 minus 9. Well, that would be approximately 40 over 26. Okay, that is, we've got our calculators available to us here. So let's run that number through a calculator and see what we get out. So 40 divided by 26 is approximately 1.54. So which one is the closest? Well, hopefully you would realize that 1.5 is the best approximation for the slope there in example 2. Okay, and these are the kind of questions we should be able to handle based on our knowledge of linear functions. So let's go on to example 3. Okay, everybody make sure you got what you need there. Slope formula specifically is something that is not on the SAT reference sheet, so you need to make sure that you have written down the slope formula. Okay, that is a formula you need to know. It's not on the reference sheet, but you are going to need it. Okay, so example 3. Says the scatter plot shown to the right shows the densities of 7 planetoids in grams per cubic centimeter with respect to their average distances from the sun in astronomical units, or AU. The line of best fit is also shown. An astronomer has discovered a new planetoid about 1.2 AU from the sun. According to the line of best fit, which of the following best approximates the density of the planetoid in grams per cubic centimeter? So, again, very wordy explanation, okay? The information that we need here is that we've discovered a new planetoid, 1.2 AU from the sun. So that means we're going to be looking at 1.2 AU from the sun, okay? And then we're making a prediction, okay? According to the line of best fit, means we're going to be interested in the point on the line of best fit, okay, that is on that 1.2 AU line. It says, which of the following best approximates the density of the planetoid? So if we look at that point, well, the density is somewhere between 4.5 and 4.75, which is the next line up. So we need one. Okay, we don't know what that density is, but we know that it should be somewhere in this range between 4.5 and 4.75. Well, the only answer we have between 4.5 and 4.75 is the 4.6. Okay, now again, when we're going over graphs, when we're going over scatter plots, I can show you examples, but it comes down to every problem is going to be a little bit different. So you have to make sure, again, that you read through the question, but don't dwell on the descriptions. Focus in on the algebra skills. You have the ability to find slope, to find intercepts, to find a specific y value based on an x value. Okay, these are the skills you need to use in these problems. So remember to take your time, read the question. What do you know? What do you need to know? And how do you find it from the graph? At this point, you're going to be working on the skill check. The skill check is, again, a little bit longer. You are not expected to finish the skill check, but you are expected to do your best on it. Okay, try as hard as you can. The first several on your skill check mimic these first several on your notes. So hopefully you've taken the notes and you can use them to help you through a few of them at least. Thank you very much for your time and attention.